Class today, 8th grade. Today we're starting our studies in a new chapter titled Forces and Fluids, Chapter 12. In this chapter we'll be studying pressure, why objects float, and how we would do work with fluids. Today we're focusing on Section 1. It's all about pressure. I'll be sharing with you my guided notes, and what I'd like you to make sure that you're going to do on your own is read through the entire text. You're welcome to watch this video and gather information, background information, by listening and seeing what Mr. Shane shares with you in terms of his notes on these slides, and then going and doing your reading so you've got some prior knowledge that you're tapping into, or vice versa. Go ahead and do your reading first and then watch this to reaffirm what it is that you read with notes that go through what you've read. Your choice. Let's begin. What is pressure? Pressure is the force per unit area that is applied on the surface of an object. When your weight is distributed over a large area, the pressure you exert on the area decreases. So pressure is a matter of two factors: how much force is applied and how large the area that force is being applied. For example, if you're standing up and you've got shoes on, your area that you're applying the pressure is the bottom of your shoe. If you try and stand on your tippy toes, you just decrease that area. Now, which one of those is more difficult? Do you stand all day on your shoe, on the bottom of your feet, or do you stand all day on your tippy toes? Obviously, probably on the bottom of your feet, because standing on your tippy toes increases the force because you've decreased the area. There's a direct relationship between these two things. If you think of a ballerina, the shoes that they have a square toe so that they can stand just on their toes. And they've got to train and train and train to be able to get their body ready and used to that type of pressure that's being applied and be able to move in that type of way. Another example is if you're walking through really deep snow, people will wear snowshoes. They increase the overall area so that the force of their body weight pushing down on the snow doesn't allow them to sink through. There's a direct relationship between, in pressure, the force per unit area. So the weight that's applied to something over the area that weight is applied. Pressure increases if the force applied increases, and decreases if the area of contact increases. So if I'm wearing those snowshoes, I'm sinking through the snow with my boots, and then I put snowshoes on, I've increased that contact area, therefore the pressure is going to decrease and I won't sink through the snow anymore. Pressure can be calculated from this formula because we have this relationship between force and area. Pressure in pascals equals force divided by area. So the force that's applied is in our numerator, the area that is applied, or the area over which that is applied, is in the denominator. Obviously, if the area gets bigger, the denominator gets bigger, which would reduce the fraction overall and make pressure less. If the force increases, you're increasing the numerator, which would make the force or the overall pressure increase. The unit of pressure in the SI system is the pascal, which is abbreviated PA. 1 pascal is equal to the force of 1 newton applied over an area of 1 meter squared, or 1 square meter. So take your meter stick and make a square with it. That's the area that you're saying how much 1 newton is applied in that area, gives you the unit of measurement for pressure. Because 1 pascal is a very small unit of pressure, pressure sometimes is measured in terms of kilopascals, which is equal to 1,000 pascals. So 1 unit of pressure is very, very small. It's a very small amount in terms of how it's measured. So a lot of times it's scaled up to be a lot larger and is counted in the thousands. Pressure and weight. To calculate the pressure that is exerted on a surface, you need to know the force in the area over which it is applied. You need to know those two factors, force and area. Sometimes the force that is exerted is the weight of an object. A lot of times, just because of the laws of motion, something that at rest is going to stay at rest. If something is sitting on top of something, so right now my textbook is sitting on top of my table or sitting on top of my desk. It is applying a force to the top of that table because its weight is being pulled down by gravity. So sometimes the force that is exerted is the weight of an object. Other times it's something being pressed into something for a specific purpose. Suppose you're holding a 2-kilogram book in the palm of your hand. You've got your textbook in your hand. To find out how much pressure is being exerted on your hand, you must first find the force that the book is exerting on your hand, which in this case is its weight. If it's just resting on something, a lot of times weight is the force that's being applied because gravity is pulling down. So weight equals mass times acceleration. You take the weight of the book times the gravitational constant of how much gravity is pulling down, and you're going to get your overall force in newtons here. So 2 kilograms times that speed of gravity, or the force of gravity pulling it down, gives you the newtons, which is the weight. Weight equals mass times acceleration. In the area of contact between your hand and the book is 0.003 meters squared. If you take your meter stick and you make this big square, and you say how much of my hand makes up that square, here's that measurement. The pressures that exerted on your hand by the book is then the force in the numerator, which we calculated at 19.6 newtons, over the area, which is 0.003 meters per meter squared. You divide that and get 6,533 pascals, or 6.53 kilopascals. You can see it's such a small unit of measurement. You're saying, well, Mr. Shane, it doesn't take a lot of effort for me to hold my big heavy textbook up just with one hand or with two hands. You can see that that's how small that measure of force is, to why it's used in that thousandths unit. One way to change the pressure that is exerted on an object is to change the area over which is applied. When you hit a nail, for example, with a hammer, the force you applied is transmitted through the nail from the head to the tip. The tip of the nail comes to a point and is in contact with the wood over a small area. The reason why we developed the technology of nails to put different pieces of wood together is because you've got a small, tiny area that is going to have a huge force applied to it, and because that area is so small and the force is so big, it's going to go through the wood, through those wood fibers, and then bind those things together. Because the contact area is so small, the pressure that is exerted by the nail on the wood is large enough to push the wood fibers apart and allow that nail to stick. Fluids have a definite shape and has the ability to flow. You might think of a fluid as being a liquid such as water or motor oil, but gases are also fluids. The air that you and I are sitting in and breathing are also fluids, because it doesn't have any definite shape and it has the ability to flow. If you've ever felt the wind or have had a fan on and you've got air that's moving, that is a fluid that is flowing. Also a fluid. Suppose you place an empty glass on a table. The weight of the glass exerts pressure on the table. If you then fill the glass with water, the weight of the water and glass together exert a force on the table, so the pressure exerted on the table increases. Because the water has weight, the water itself also exerts pressure on the bottom of the glass. This pressure is the weight of the water divided by the area of the glass bottom. It increases. As a result, the pressure exerted by the water increases. So not only does an object that's sitting on top of a table apply a pressure, so does the water apply a pressure to all the different surfaces that it's actually touching, and apply a pressure to the bottom of this overall glass, because all this weight is being pulled down. So pressure in a fluid can be applied in multiple directions and over multiple areas, because it doesn't have a definite shape. It fills its container and then therefore applies pressure to its overall container. When the height of a fluid is greater, the pressure at the bottom of the container is greater. This is always true for any fluid or any container. So if you have more of something filled up, it's obviously going to apply more pressure because it has more weight, and that height influences as well, because now you've got more gravitational force that's pulling down. The greater the height of a fluid above a surface, the greater the pressure on the surface. It's like a football field underneath water, and as you go down, you're actually trained to try and pressurize your sinus system in your head. Otherwise, you wouldn't be able to concentrate down there. You have too much throbbing. You actually have to try and fill air into your airways and kind of release air as you're going down, because as that pressure increases, it's going to apply a greater force on the air that you have inside your body. And the same thing as you're coming back to the surface. There's ways in which they train you so that you can do that safely. As the height of the fluid above you increases, the weight of the fluid above you also increases. As a result, the pressure exerted by the fluid increases with depth. So as you are down at this 50-meter range, in my experience, you can't just go zooming up to the surface, because at the 50-meter depth range, all that air has been compacted and pressurized into a small area. If you go up too fast, that air expands because there's less pressure, and it can damage your lungs and your airways. It's called the bends if you do that while you're scuba diving. So you have to go up at a slower rate than you went down at, and you have to be constantly like getting rid of air and breathing out as much as you can, because that air is now expanding into a larger area as you get closer to the surface. The further you go down, the more that pressure is exerted. The pressure that is exerted by a fluid is due to the weight of the fluid. Is the pressure in a fluid exerted only downward? Well, that would be no. Pressure is exerted in all directions by a fluid because there's a force that's being applied in all directions. The pressure on an object in a fluid is exerted on all sides, perpendicular to the surface of the object, no matter what its shape. So you drop this metal cube in, there's pressure this way because of gravity and also because of the water that's above it. There's pressure this way because of the water that's below it. There's pressure on the side, pressure on the side, pressure on the side. So a submarine has this full metal hull that's intact because there's pressure that's being applied to all different parts of that as it's submerged as it's underwater. Atmospheric pressure. Because air is also a fluid, we can think of air as applying a pressure to anything that is within it. The atmosphere at Earth's surface is only about 1/1000th as dense as water. However, the thickness of the atmosphere is large enough to exert a large pressure on the object at Earth's surface. So just like we're underwater a long ways and you can feel the pressure, technically think about how much air is between us and all of the atmosphere. Technically all of that air is applying a pressure to us. Now, we don't necessarily feel that all the time, and we're going to understand why that is. When you're sitting down, the force pushing down on your body due to atmospheric pressure can be equal to the weight of several small cars. Seriously, all the air that's pushing down on us is equal to several small cars, like thousands and thousands of pounds? How do I not feel that pressure? Well, atmospheric pressure is approximately 100,000 pascals at sea level. But the reason why you don't feel it is because your body is actually filled with fluids as well. And those fluids are more dense than air. So blood is a liquid similar to water, even though it's a little bit more dense than water. It has water in it. It also exerts a pressure. So the fluids in our body, the way that our body is designed by God, is so miraculous. It combats that weight of a couple thousand pounds or a couple small cars that's pressing down on us. And guess what? It pushes back. And when those things push back, they cancel each other out. The pressure exerted outward by the fluids inside your body balances the pressure exerted by the atmosphere. So we don't feel this massive weight. We don't feel like it's difficult to move through air because we've got fluids inside of us that push back. Going higher. As you go higher in the atmosphere, atmospheric pressure decreases as the amount of air above you decreases. The same is true in an ocean, lake, or a pond. The water pressure is highest at the ocean floor and decreases as you go upward. A barometer. An instrument called a barometer is used to measure atmospheric pressure. The space at the top of the tube is a vacuum, means that it doesn't have anything that can exit out of it. It has this solution inside here, and then there's no way for any of that to escape. Atmospheric pressure pushes liquid up the tube, so the pressure that's from the atmosphere, all the air that's from here all the way to the outside of the atmosphere pushes down naturally, and it forces this liquid up the tube, and you can measure then how much pressure is being applied, and that pressure in the atmosphere fluctuates. The liquid reaches a height where the pressure at the bottom of the column of the liquid balances the pressure of the atmosphere, and then it tells us what that pressure is. As the atmospheric pressure changes, then, the force pushing on the surface of the liquid changes. As a result, the height of the liquid in the tube increases as the atmospheric pressure increases. If you've ever paid attention to the weather, there is a way in which the air pressure or the atmospheric pressure in the barometers are calculated, and a lot of time is related to the different types of weather patterns that you hear. You might hear weatherman say something about a high pressure system, and really bright sunshiny day, clouds that are really high in the air show up. You might hear something about a low pressure system, which brings different types of inclement weather and precipitation. The difference between those types of pressures often is corresponding with the different types of weather patterns that come in, just a way in which that atmosphere sometimes changes and fluctuates for us here on Earth. Quick little section check. Question 1, what is the unit of pressure in the SI system? Gram, liter, Newton, Pascal. That would be Pascal. Question 2, a substance without a definite shape and with the ability to flow is known as a fluid. Don't confuse this with a liquid. Gases such as air you breathe are also fluids, not just liquids. Pressure in a liquid decreases, increases, remains the same, or vanishes with depth. The further you go down, the greater that pressure increases. You may have experienced this if you dive into a pool, you swim down to the bottom. The deeper you dive, the more pressure you feel. Thanks for following along with our notes. Make sure that you've gone and taken care of your reading, and then use both of those resources, this video and your reading comprehension, to complete your reinforcement. God's blessings.